Welcome back, guys. So today we are going to continue our question decoded series, and as you can see, this question is from UI Post-UTME question. Let's move. Okay, two objects P and Q have the same weight W in air. Don't forget your weight in air is the same thing as the real water, the real weight. So I can assume that my water, the weight of P in water in air is equal to the weight of water, weight of Q in water in air. Let me assume both of them is now equals to W. When completely immersed, and that is where most students usually have issue. When something is completely immersed, the volume of the object immersed must equal to the volume of the liquid displaced. Take note of that. Volume when completely, completely immersed, the volume of the object immersed must equal to the volume of liquid displaced. So we know that volume of object object immersed must equals to volume of water. Let me call volume of the object immersed to be VO, must equals to volume of liquid displaced, volume of liquid the water displaced. Okay, displaced, let me call it VD, like this. Okay, moving on. The apparent weight of P is 3W/4. That is, apparent weight is the weight of something in liquid or in a fluid. Okay, so apparent weight of P, let me call it WP, which is apparent is equals to 3W over 4. So we have something like this, and we have the y that of Q, that is the apparent weight of Q. Q apparent is now equals to W over 2. It can be concluded that number one, volume of P is twice that of Q, volume of Q is twice that of P, density of P is twice that of Q, density of Q is twice that of P. You can see what they are considering there is the volume and the water and the density. So now let us compare, let us find the volume of P and water and Q, and we compare it with the density. Now, okay, how do we go about that? We have apparent weight, we have real weight. Which formula relates the two of them? You have your upward to upthrust. If you can still remember, you have the weight in liquid, you have your weight in air, and you have your upward to upthrust. So what's the formula for our upthrust? Upthrust equals to real weight, or let me say the weight in water, weight in air, minus weight in water, weight in liquid, or let me say fluid, anyone you like. Okay, or you can say upthrust equals to real weight. Real weight is the weight in air minus apparent weight, which is what? Which is weight in liquid. So okay, since they are using apparent here, let me use apparent. Okay, so we have something like this. What is the formula for upthrust? We have rho Vg. So we have rho, which is density, multiplied by volume, multiplied by acceleration due to gravity. But don't forget that your V is volume of liquid displaced. Everything concerning upthrust is liquid. It's about the liquid that you immerse the object in. So must equals to the water, the weight in air, okay, minus weight apparent weight. Okay, so making the weight in air the subject of the formula, we have, okay, what are you going to have? You've been given the apparent weight. Okay, you've also been given the real real weight. We don't need to make anything the subject of formula. Okay, so moving on. For P, what do we have? We have roll VDG. Okay, we are going to consider P now, but don't forget that the volume of liquid displaced, the volume of the object immersed must equal to volume of liquid displaced, since they are completely immersed. So I can assume my volume of liquid displaced, which is VD, must equal to the volume of the object immersed. So instead of writing this VD, I can write it as VP, which is the volume of P. Okay, multiplied by acceleration due to gravity. We now equals to, what about the weight in here? What is the weight of P in here? We have W minus apparent weight of P is 3W over 4. So we have minus 3W over 4. So we have something like this. If you solve that one, what do you get? You have rho VPG. We now equals to, what is W minus 3W over 4? That will give us W over 4. So we have something like this. Okay, what about the next one? For Q, what do we have for Q? Q is going to be rho Vg, which is upthrust equals to weight in here minus apparent weight. So upthrust is rho Vd volume displaced. But instead of using volume displaced, what can we use? We can use the volume of the object, because volume of object in mass equals the volume of liquid displaced. So what's the volume of this object is what is Q. So we have Q. Okay, we have volume of Qg must now equals to what we have, the weight in water, weight in air. You use the same formula, weight in air minus apparent weight. So what do we have? We have rho V Qg. We now equals to what's the weight in air? We have W. Don't forget, it is also W minus apparent weight. That's W over 2. So what do we have? If you solve that one, what will you get? Rho VQ. Sorry, we have rho VQ G. We now equals to W over 2. If you solve this one. Now, so this is our equation 1. So you can call this our equation 2. So what do? You can divide equation 1 or equation 2 by equation 1. Oh yeah, let's say divide equation 2 by by 1, by equation 1. So what do we have? We have rho VQG. Okay, divided by what? Sorry. We have divided by what do we have for P? We have rho VPG equals to, then we have your weight of Q, equation 2, which is W over 2. Everything divided by, for 1, we have W over 4. So what are we going to have? We have a head. We are using the same liquid. Everything about upthrust is about the liquid. So since we are looking at the same liquid, like they immerse both of them in the same liquid, we are going to have the same density. So roll will cancel roll. What we have cancellation due to gravity, we also cancel each other. So what do we have? We have VQ over VP. We now equals to, what's this? We have W over 2. Okay, let me say what W over 2, which is multiplied by 4 over W. So this cancel this. So you have 1, 2, you have 2. So what do we have? VQ. Okay, we have VQ. VQ over VP. We now equals to what? 2 over 1. If you cross multiply, what do you get? Finally, you have your VQ equals to 2VP. So you can see that the volume of Q is twice the volume of P. So which one is correct then? The volume of Q is what? Is twice that of P. So we know that angle 2 is correct. So this is wrong. This is correct. So what about the density? Let's now compare the density. If you want to compare the density, well, what should we do? We just have to, from our formula, which is we have density equals to mass over over volume. And since they have the same the same mass, they have the same weight in air. For something to have the same weight in air, that they must have the same mass. So the mass of P is equal to mass of Q. Let me just call it mass. So I can assume my density. So let's say density of P. This is density of density of P is equivalent to mass over volume of P. So what do we have? Making M the subject of the formula. Okay, I'm going to be using this this small space. Let me just use this small space to solve it. So the mass of P, which is M, equals to density of P multiplied by volume of P. Density of P, which is density of P multiplied by volume of P. The mass of Q will also equals to the density of Q multiplied by the volume of Q. So since they have the same mass, they will be equal. So this equals to this equals to this. So we have rho P. Okay, rho P VP must equals to rho Q or VQ. Okay, and we all know that they said VQ is 2VP. So instead of writing VQ, I can say rho P VP will now equals to rho Q. Instead of writing VQ, what do I write? I'm going to write 2VP. VQ equals 2VP. So VP will cancel VP. So what do we now have? Rho P, density of P equals to 2 rho Q. So that's what we have. That the density of P is equals to twice the density of Q. So where is that one? Density of P is twice that of Q. So you can see the Roman got 3. Density of P is twice that of Q. So this is also correct. Definitely this is what this is wrong. So what are the correct option, everybody? Roman we got 2 and Roman we got 3. Hence our correct option is what? D. Thank you very much, everyone. Like, subscribe, and join our channel. Thank you.